Good morning, sir. Myself in Devi. I am from ECE. My roll number is 2340180432. Today my topic is autocorrelation in Whitson stationary process and the subject code is 23ECA 301. First we can go through the introduction to autocorrelation. Autocorrelation measures the relationship between a time series and a lagged version of itself. It is a crucial tool for identifying patterns and dependencies in time series data. Understanding autocorrelation is essential for modeling and forecasting time dependent data. Next, we can go through the definition of Whitson stationary process. A Whitson stationary process has a constant mean over time. The variance of Whitson stationary process is also constant and it does not change with time. The covariance between any two time points depends only on the time difference, means lag, not on the specific time. Next, we can go through the importance of autocorrelation in Whitson stationary process. Autocorrelation helps in identifying the presence of trends or periodic patterns in Whitson stationary process. It allows for the analysis of memory effects in time series data. Understanding autocorrelation is vital for the development of the correct statistical models. Next, we can go through the mathematical representation of autocorrelation. The autocorrelation function is also known as ACF. It is defined as the correlation between observations at different time lags. The below figure shows the autocorrelation function. In x-axis they can take lag and y-axis autocorrelation. These two are the mathematical representation of autocorrelation. Next, we can go through the mathematical representation of autocorrelation. This is the formula, and where the mu is the mean and sigma square is the variance and k is the lag. Next, we can go through the properties of autocorrelation function. The autocorrelation function is a symmetric, meaning the autocorrelation function at lag 0 is always equals to 1, indicating perfect correlation with itself. The autocorrelation function typically decreases at the lag increases, reflecting decreasing correlation with greater time differences. Next, we can go through the example of autocorrelation in Whitson stationary process. Consider a Whitson stationary process generated from white noise with added lag terms. The autocorrelation function for this process will show significant values at small lags and diminish as the lags increases. This pattern allows for insights into the underlying structure and dynamics of the time series. This is the picture of the autocorrelation in Whitson stationary process. Next, we can go through the applications of autocorrelation in time series analysis. Autocorrelation is widely used in econometrics for modeling economic time series data. It is also essential in signal processing for filtering and prediction tasks. Moreover, it plays a key role in diagnostic models such as ARIMA for time series for forecasting. Next, we can go through the testing for autocorrelation. Several statistical tests such as Durbin-Watson test helps access the presence of autocorrelation. A significant autocorrelation suggests that the model may need adjustment or refinements. Visualization tools like autocorrelation function and PACF plots provides a practical way to analyze autocorrelation. Next, we can go through the limitations of autocorrelation. In limitations of autocorrelation, the autocorrelation does not imply causation, it merely indicates a relationship between observance. The below figure shows the relation between observations. And next we can go through the next limitation. Non-stationary process may exhibit misleading autocorrelation patterns. It is essential to ensure that the data meets the Whiteside stationary assumptions before applying autocorrelation analysis. Next we can go through the conclusion and for future directions. Understanding autocorrelation in Whiteside process is vital for effective time series analysis, and these are the future research directions of autocorrelation. Next we can go through the some other future researches. Future research may explore advanced methods for handling non-stationarily and complex dependencies. Continued advancement in computational tools will enhance our ability to analyze and interpret autocorrelation in real-world data. Feel free to modify and of the content or structure to better suit your presentation needs. Thank you, sir.